the today's class we are seeing the last topic of this unit. It is the third unit, entropy, and this last topic is nothing but the third law of thermodynamics. It is also known as the Nernst heat theorem. Nernst is the name of scientist. So in 1906 the Nernst proposed a general principle supported by the series of experimental evidences on the problem of atomic heat at low temperature. Means what is the functioning or what is the problem of atomic heat at low temperature, because we are seeing all the heat process that is at the source at the higher temperature, sink at the lower temperature. But what is the problem? Problem of atomic heat at low temperature? Actually it was proposed as a new heat theorem, but its importance is so great that today it is recognized as the third law of thermodynamics. So that's why Nernst heat theorem, it is known as the third law of thermodynamics. The statement of the third law of thermodynamics is, according to Nernst, the heat capacities of all solid tends to zero. The heat capacities of all solids tends to zero as the absolute zero temperature at the absolute zero of temperature is approached. And that the internal energies and entropies of all substances become equal there, and that internal energies and entropies of all substance becomes equal there, approaching their common value asymptotically tending to zero. Approaching their common values asymptotically. Tending to zero. So this is the statement of Nernst heat theorem. That is, according to Nernst, the heat capacities of all solids tends to zero as the absolute zero of temperature is approached. When the absolute zero of temperature approached, the heat capacities of all the solids tend to zero is, and that so due to this heat capacities of all the solids tend to zero, so that's why internal energies and the entropies of all substances becomes equal. So approaching their common values asymptotically tends to zero. So this is the statement of Nernst theorem. So this simple statement of Nernst follows neither from the first law of thermodynamics, that is the first law of thermodynamics is nothing but the law of conservation of energies, or nor from the second law, that is the second law of thermodynamics, and it is thus of the nature of a new law. This is the new law, means we can't see the statement in the first law or the second law. This is not from the first law or second. So that's why It is neither from the first law nor from the second law, and it is thus of the nature of new law. So usually called as the third law of thermodynamics. So this statement is known as the third law of thermodynamics. So this theorem is useful in explaining the nature of bodies in the neighborhood of absolute zero temperature. When we are seeing the neighborhoods substances, so it denotes the nature of the bodies of the neighborhood of absolute zero temperature. So in terms of entropy, the law may be stated as, in terms of entropy, it states that the new statement in terms of entropy, at absolute zero temperature, the entropy tends to zero. The entropy tends to zero, comma, and the molecules of the substance or a system are in perfect order, that is well arranged. Okay, so this is the next statement of Nernst heat theorem in terms of entropy. So it states that at absolute zero temperature, the entropy tends to zero. So because entropy depends on the temperature, we know that second law of thermodynamics, dq is equals to Tds. So in that, temperature is the most important quantity. So at absolute zero temperature, when the temperature becomes zero, the entropy tends to zero, means entropy becomes zero, and the molecules of the substances or the system consists of a number of molecules of the substances or any substance, gas, liquid, solid, so or a system are in a perfect order, that is well arranged. So this is the second statement of Nernst heat theorem. So in all heat engine, there is always the loss of heat in the form of conduction, radiation and friction. So therefore in actual heat engine, we know that the Q1 by T1 is not equal to Q2 by T2, because T2 is the lower temperature and T1 is the higher temperature, that is the temperature of the source and the sink. So that's why the differences of Q1 by T1 minus Q2 by T2. Okay, we know the difference. So this difference is not zero. When we calculating this difference, so this difference is not zero. So but it is a positive, means it has the positive value, which already studied in the previous classes. So that is the difference Q1 by T1 minus Q2 by T2 must have the positive values. Okay. So when the cycle after cycle is repeated, the entropy of the system increases and attains a maximum value. Okay. When cycle after cycle, there is a number of cycles. So after that, the entropy of the system increases and attain a maximum value. So when the system has attained the maximum value, the stage of stagnancy is reached, that is no work can be done by the engine at this stage. Okay, so this is already seen in the entropy of the universe, that is the principle of increase in entropy. That means entropy of the irreversible process always increasing. One stage comes where there is no work done by the any engine. Okay, so in the universe the entropy is increasing, and we all know that the entropy of the universe is always increasing. That is the principle of increase in entropy. The entropy of universe become increases, and ultimately the converse will also reach a maximum value. Okay, universe will also reach at the maximum value of entropy when no work will be possible. When the entropy becomes maximum, no work performed by the any engine. Okay, so with the increase in entropy, the disorder of the molecules of a substance increases. That means when there is an increase in entropy, the temperature will also be maximum. So at that time there is a random motion of the molecules of the substances. That means the entropy is also a measure of disorders of the molecules. That is the arrangement of molecules. When the entropy increases, temperature also increases, because due to the temperature increases, entropy increases, and one stage is reached. At that stage no work is done. So that means the entropy is a measure of disorders of the system. Okay, so with the decrease in entropy, the disorder decreases. When the entropy decreases, here that entropy tends to 0. Okay, the disorder, with the decrease in entropy, the disorder decreases, and at absolute 0 temperature, the entropy tends to 0. Here the statement, at absolute 0 temperature, the entropy tends to 0. Okay, and the molecule of the substance or a system are in perfect order, that is the well arrangement. So this is known as the third law of thermodynamics, as we describe here. Okay, so this is the general statement of Nernst heat theorem. This is the first statement, and in terms of entropy, this is the second number statement. Okay, so in this way our third unit is completed. Okay, so we will perform a test. I will give you a test for solving. Okay, thank you.